Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be going through the configuring a data center overlay IBGP learning byte. All right, so here is our topology. Here in this topology, we have 5 devices. We have spine 1, spine 2, leaf 1, leaf 2, and leaf 3. And since we're using IBGP, they will all be using the same autonomous system number for the IBGP peering sessions. So that number of 64665 for the autonomous system number is marked there on the topology on each device. And then the loopback addresses, which are already being passed around by the underlay network, which is in our case eBGP, is shown on the left. We see spine 1 that uses 192.168.100.1. Spine 2 uses .2, leaf 1 uses .11, leaf 2 uses .12, and leaf 3 uses .13. And spine 1 and spine 2 will also be acting as route reflectors. And spine 1 will be using the cluster ID of 10.1.1.1, and spine 2 will be using the cluster ID of 10.2.2.2. So with that being said, let's go ahead and jump to the CLI and get this going. All right, so here is the CLI for spine 1. Let's go ahead and go to Protocols BGP. And have a look what we have here. And you can see here we do have the underlay configuration that is on spine 1 as well as the other devices in our little data center here. So let's go ahead and jump into group DC overlay. And let's go ahead and configure this. So let's first set the type to internal. If we don't set a type, it will default to external, and we don't want that. And then let's go ahead and set the local address. That's going to be the loopback address of spine 1. Then we also have to set the cluster ID, and that's going to be 10.1.1.1, and recall that spine 1 is a route reflector. And then we need to set the neighbor parameters. And so we'll set neighbor 192.168.100.2, that is spine 2, and then we'll set 11, that's leaf 1, 2, or rather 12 is leaf 2, and 13 is leaf 3. So we can see the configuration there. That looks good. Let's go ahead and commit that configuration. And I'm going to copy this and paste it into spine 2 and make a few adjustments to save on some time here. So let's go to Protocols, BGP, Group, DC, Overlay. We'll load this in. You can see the configuration here. Now we need to change a few things. First of all, the local address needs to be the loopback address of spine 2. And then we need to change the cluster ID to 10.2.2.2. And then we need to set the neighbor. We set spine 1 as a neighbor. And we can delete spine 2 as a neighbor since we are already on spine 2. Now, if you were to leave spine 2 in there, in the configuration, that is the neighbor of spine 2, the loopback address of spine 2, on spine 2, it wouldn't hurt anything. I like to remove it just to keep a clean configuration. But if you're doing something, say an expert level lab exam, I would just leave it in. Time is of the essence with those things. So I would not take it out. I would copy and paste as much as possible. So in that instance, you could leave it in. It wouldn't hurt anything. But with what we're doing here, I want to remove it just to keep a clean config. So let's go ahead and commit that. And then let's jump to leaf 1. Now this is going to be a little different since the leaf is not a route reflector. We only need to set a pairing sessions or 2 pairing sessions with spine 1 and spine 2. So we'll go to BGP Group DC Overlay, and we'll set the type to internal, local address to 192.168.100.11. That is the loopback address of leaf 1. And then we'll set the neighbor to 192.168.100.1. That would be spine 1. And then we'll set the other neighbor to .2, which is spine 2. And one other thing that I did forget on spine 1 and spine 2 is we need to set the local AS. That's 64665. Now there is an autonomous system already set in the routing options, but it's different than what we have here. So let's go ahead and set that there. I'll commit that. We'll jump back to spine 1 and do the same. Set the AS 64665. Commit that. And here spine 2 will do the same. Set the local AS to 64665 and commit that. And then we'll go back to leaf 1, and I want to grab the configuration from this because we'll be able to copy and paste that in on leaf 2 and leaf 3 to save some time. All we have to do here is change the local address to the loopback address of leaf 2, and then we'll jump to leaf 3 and do a similar configuration. And let's commit that configuration. And then let's jump back to Spine 1 and have a look at the BGP sessions. You can see here that all the BGP sessions are in the established state. We have these 3 sessions that are part of the underlay, and then we have these 4 sessions which are part of the overlay. And so that's great. We have everything established, but there is a problem here. And I left this out on purpose because I wanted to make a specific point on what's going wrong or what we need to do next. And you can see here that we're passing INET routes. We're passing IPv4 routes. And that's not what we want for an overlay network in a data center. We want to be able to pass EVPN routes. And so we need to make a change. We set family EVPN signaling and commit the configuration. And we need to do that on all devices here. So set family EVPN signaling, commit the configuration. Spine 2, let's do this on leaf 1. Set family EVPN signaling, commit. Set family EVPN signaling, commit that. And set family EVPN signaling and commit that. And then let's jump back to Spine 1 and see what we have. We see the BGP summary output. We have the sessions established, and instead of INET.0, we're seeing BGP.EVPN.0. And that's exactly what we want to see. The overlay network is set up to pass EVPN routes. And there's no routes right now because we don't have any VXLAN parameter set up, nothing with EVPN set up. So we're not passing any EVPN routes yet. But those are topics that I'll save for another learning byte, so watch out for that as well. And so with the overlay network, we have everything configured and working exactly how we want to have it. So this does bring us to the end of this learning byte. In this learning byte, we demonstrate how to configure and verify IBGP in a data center overlay network. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.